Hey everybody, we're going to talk about medians and centroids, and we're going to do some altitudes and orthocenters today. So a median is a segment joining a vertex to the midpoint of an opposite side. So the three medians of a triangle intersect at a centroid. So as you can see up here, we went from a vertex down to a side and it cut it in half. It did not make a right angle though. So unlike the circumcenter, where circumcenter cuts a side in half and makes a right angle, this is not the case. Our medians here are AE, BF, and DC, with P being our centroid. So with centroid, there's special properties. So let's take segment AP, for example. AP is equal to 2 times PE, whereas PE is equal to half of AP. Okay, so that angle from the vertex to the center is always the longer part of it. And if we take AE, if we take this whole segment of AE, we can find AP is equal to 2/3 the length of AE, and PE is equal to 1/3 the length of AE. Okay, so this little part here is 1/3 the distance, where AP is 2/3 the distance. So we're going to do a couple examples. So JK is 22, KN is 13, and OL is 18. So we can use the fact that KM is cut in half, so half of 22 is 11, and L, we know KN and NL are equal, so this is 13. So if we were going to find KL, we just add 13 plus 13, which is 26. JO is the same thing as OL, so it's 18, and JL is going to be 18 plus 18, which is 36. So over here, I'm going to just fill in the information that we know. So if we're going to find ZV is going to be 2 times 28, which is 56. ZY is going to be half of 60, which is 30. ZU is going to be 2 times 25, which is 50. TY is going to be adding 60 plus 30, which is 90. And XV is 28 plus 56, which is 84. 28 plus 56, which is 84. Okay? Again, I'm just going to fill in the information that we know. So GD here is the smaller part of this median. So 8 divided by 2 is 4. AD is the whole distance, so 8 plus 4 is 12. We have CG, which is 2 times the segment, which is 14. And GE is 2 times 5, which is 10. And BE is 5 plus 10, which is 15. Okay, so I just filled in the information that we know. So here we have to use the 2/3 and 1/3 stuff, okay? So TX is associated with the length of 27. So what we need to do is you need to take 27 and divide it by 3. So that means this is 9, and 9 times 2 is 18. So TX is 18, and XU is 9 that we found. So I find the easiest way is taking this, dividing it by 3, and multiplying it by 2 then to find the segment. We need to find ZX here. So we do 18 divided by 3, which is 6, and multiply it by 2 to get 12. And XW is 6. And then RX here, if we take 21 divided by 3, we get this to be 7. 7 times 2 is 14. Okay. All right, on the reverse side, we have DH is 51, GF is 60, and EI is 57. So I'm just going to talk through these. So DJ is 51 divided by 3 times 2, which is 34. JH is 17 that we found. GJ is 60 divided by 3, which is 20. And JF is 40 that we found. EJ, 57 divided by 3 is 19. 19 times 2 is 38, and JI is 19. We have SR to be 21, VU to be 8, and PT to be 15. So SB is going to be 21 divided by 3, which is 7. VR is 14, 7 times 2. QV is going to be 8 times 2, which is 16. And QU is going to be 16 plus 8, which is 24. PV is 15 divided by 3, which is 5. 5 times 2 is 10. And VT is 5. Sorry if you needed to pause that again. Okay. AF is going to be half of 64, which is 32. FC is also going to be 32 because they're equal, and we're looking at the 64. BG is going to be 72 divided by 3 and multiply it by 2 to get 48. And that means that GF was 24 that we found. AG is 27 times 2, which is 54. 54. And AE is 54 plus 27, which is 81. So TN is 16, MQ is 23, and RP is 18. Okay. QT is going to be half of 16, which is 8. QN is 8 plus 16, which is 24. QP is going to be the same thing as MQ, which is 23, and MP is 23 plus 23, which is 46. RT is going to be 18 divided by 3, which is 6, and TP is 6 times 6, which is 12. 6 plus 6, which is 12. And the last one here, we have DF is 50. We have CF, which is 42. And we have BH, which is 22. So HE is going to be half of 22, which is 11. EF is going to be half of 50, which is 25. HF is going to be 42 times 2/3, so 42 divided by 3 times 2 is 28. DE is going to be also 25. CH is going to be half of 28, which is 14, and BE is 22 plus 11, which is 33. Okay. On the bright side, Altitude doesn't have any math information about it. The only ones that did were the Circumcenter, Incenter, and Centroids. So the segment joining the vertex to the opposite side so that it is perpendicular. I spelled that wrong. So here is the vertex and it's connecting to the opposite side at a perpendicular angle. So that is the altitude, this line here. Altitudes can be inside the triangle for this example. So this is A. It can be outside the triangle. So that means this is A. Or it can be on the triangle, and it only happens when you have a right triangle. The three altitudes of a triangle intersect at the orthocenter. So in the diagram here we have AE, BF, and DC as your altitudes, with P being the orthocenter. So this is a centers review. So the three blank of a sides of a triangle intersect at the circumcenter. So the circumcenter is the intersection of all perpendicular bisectors. The blank of the blank of the angles of a triangle intersect at the incenter. So the incenter is where all angle bisectors intersect. The three blank of a triangle intersect at the centroid. Today we learned that it is median. The three blank of a triangle intersect at orthocenters, that is altitudes. So what is equidistance from the vertices? That is the circumcenter. And what is equidistance from the sides? That is incenter. Okay. So the back of this page is the Name That Center worksheet. So what we're going to do is we're going to determine what center it is based on the information that we're given. So it can be either circumcenter, incenter, centroids, or orthocenters. So you kind of need to know all your information about these so that you could determine which one it is. So this has to deal with angle bisectors, so that is incenter. Here we have perpendicular lines that meet at sides, so that can be either circumcenter or orthocenter. However, circumcenter cuts sides in half, orthocenter does not, so this is orthocenter. What cuts sides in half? That's either circumcenter or centroids. However, the circumcenter has right angles. This does not, so this is a centroid. Okay, cuts sides in half and is perpendicular, so that is circumcenter. Equidistance from vertices is circumcenter. Cuts sides in half but does not make right angles is centroid. It's very similar to this one up here. Equidistance from sides is incenter. Makes 90-degree angles with sides but does not cut in half. That's orthocenter. Angle bisector is incenter. And lastly, cuts lines in half, makes right angles, is circumcenter. So I hope this helps talking about centroids and orthocenters, and that's it. So see you later.